Our background for this project is the frequencies of the accidents in the area where the traffic light control isn't very advanced. In the rural area, intersections usually have unclear direction and signals. For example, you cannot know if always you can turn right here. If there are directions given, they are mostly painted on the road and lack of the maintenance, making them hard to be seen. Therefore, more accidents happen in this area.
And even worse, there's no lights indicate when the pedestrian can cross, and the roads in the rural areas are usually long and straight. And this makes the drivers more inclined to accelerate their cars to full speed, thus reducing their visibility and their braking timing. So the pedestrians are more susceptible to be hit by these vehicles when they are trying to cross the road. And we think that by adding a working traffic light in these areas, it will help reducing these accidents.
The circuit that we represent is a traffic light circuit for an intersection. It is an intersection where you can turn both left and right, and each route has a footpath for crossing to the opposite side of each route. Our traffic lights will consist of lights to notify pedestrians on both sides of the road and traffic lights to notify the direction in which vehicles can turn by specifying left turns, straight turns, and right turns respectively. All four routes, this traffic light circuit uses the same timer for the entire circuit of 15 seconds. After 15 seconds, the directions in which vehicles can pass on each route will change depending on which route is open to pedestrians.
There will be a total of 3 format change. When all 3 formats have been changed, the direction open for pedestrian to cross will change to open another part. The direction that vehicle can pass on each road will change. This will be repeated until all 4 roads are complete and the loop is repeated.
Okay, so in the first place, we our circuit compound of four opponents. The first one is main, the second one is control unit, the third one is logic unit, and the fourth one is timer. And also we now gonna create a timer. As we know, our design is the timer of the circuit will be 15 seconds per one tick. So what I'm gonna do is the first one is using a standard clock here. So this is the ordinary clock, and with our simulations we're gonna take it auto tick frequency at 1 hertz, that means 1 tick per second, and then we're gonna use our lovely counter, and then pair it, and then setting it as a 4-bit data, because our 4-bit we will count up to 16. In this case we use 15 seconds. Then the output of this module, we have 2 sections, which is this line, as we use as a timer out, and the second one is our timer display. So for this, we finish our timer unit.
Okay, my groupmate has talked about how circuit, how we can make a sequence of the if statement, which is a big one, and the sub-statement one right here. And what about how can we determine which statement or sub-statement that which one of light will turn on or turn off, will be a red or green? I will explain about it. So we have a raw counter here that is count up to 3. Count up to 3. So it have a 2-bit signal here. And this module is for one hot sequence that we use for each statement here. Now we have a 4-bit for red hot and 2-bit from a raw counter. We combine this one to use in the ROM implementation. Our ROM is have a 6-bit input, so it can reserve about 64 address here, and then we know about the statement 6-bit input here from our two table, and I use ROM implementation to determine about the output, which light will be turned on, green and red here. You can see we determine each address. This are 12 pattern that we use in a ROM implementation.
Okay, and the last one of our module, but not least for this circuit, is our logic unit, which the purpose of the logic unit is to divide the value from the time logic unit, which in this logic unit it will gonna have 4-bit of input and 4-bit of output, which in this module is will only doing minus, because in time in you we will have a time in as 15 count up, but in the traffic light we need a countdown. So we're gonna use a 4-bit divider 4-bit subtractor to use in this case, which we the minus we will use as 1111 or 15 to minus with the time in, which is a 4-bit provider from the counter.
And that's the end of our video. If you have any questions, feel free to ask us through our emails. Thank you.